Alright, so now we are going to proceed forward with the application of or the submission of the job. So if we go to the job module over here, so over here now I'm in the job module and I need to click pretty much the first icon here that says create job. If I do that, then I need to provide a name for the job. So I will call it, for instance, job steel connection, for instance, something like that. That's right. And then I say continue, and the source here would be for this job is the model pretty much. The other option is an input file. So this is something that we will discuss in later videos, like more advanced options if you want to run a model from an input file. So I'm going to click continue right now, and then we are going to get this dialog. Pretty much here for the submission, I keep everything as it is. For I think the name here is it's not correct. It's called John. It's not job, so we can modify it later. That's all right. So now you can write the description, describe the job if you want. I will leave this as it is, like with respect to the job type. I will not modify anything here. The only thing that you can do perhaps is if you go to parallelization. If you are running this from your laptop or a PC, or even if you're running this through supercomputer, you can make use of multiprocessors. So right now, for instance, I have my computer. I have like 6 or 8 processors, so I can use like maybe increase here to use like multiple processors to run the analysis, and this of course will save time. That's it. That's pretty much it. When it comes to static analysis, I don't need to modify anything else. This is for the memory, the amount of memory that can be allocated for the analysis. So I keep it as it is at 90%. If you are running other intensive tasks on your PC, maybe you want to decrease that. Precision, you don't need to worry about that. This is mainly for explicit analysis. Here, again, nothing I need to do here with these options. These are all like advanced stuff that you can check later on. So that's it, and you can of course create like a submission time, like if you want to submit this at a later time, but this is not the case over here. We just want to submit right away. So I'll say OK. So now it says here that the job has been created, but let me modify the name again because I missed the name over here. So let me click, I clicked on the manager, and over here I can click on rename. Let me rename it. Let me make it job monotonic, since this is a monotonic load that we are applying at the beam end. And I can say OK, that's fine. So now the only thing remaining is to actually submit the job. So over here I have different options. You can write an input. If I click on that one, what will happen is, as you see, let me put this on the side. Alright, so right now this is the directory, the work directory, and right now it has the CAE file for my model, and it has this journal file and this recording file that automatically generated by ABAQUS. In case something crashed, you can regenerate your work. So right now, the first option is write input. This one, if I click on it, actually, what will happen is that you see right now you get this input file. So this is a text file, and this text file you can just open it in. Let me open it with Notepad, like any file. And this one is pretty much here. It is like this is a long input file. This input file includes pretty much the description of your entire model, the loading steps, the boundary conditions, the loads, the interactions that we created, everything will be over here. And pretty much you can modify this input file, and then you can run the modified version of this input file. But this is something that we can do later on in our tutorial series. But for now, pretty much that's it. So this is the how to create an input file. I will delete this file for now. And the second thing is the data check. So this is if you want to check your model to make sure that everything is correct, like you didn't forget to define materials or sections or something was missing. So you can click on that data check to do that. But I will not do that. That's fine because I'm going to submit anyway. So if something is missing, I'm going to know it. That's it. That's pretty much it. I just need to submit. And the other two buttons over here, this is one called the monitor. So this is what we are going to look at once we click submit, to trace and or to monitor pretty much what's happening during the increments, the analysis increments. And once this is finished, we can look at the results. So I'll go ahead and click on submit. So you see, once I clicked on submit, so now it says status is submitted, and now it says it's running. And you see here all these files that are being generated in my work directory. The most important one is this one. This is the ODB file. So this is the one that all the data is going to be saved in. So right now it's 8 megabytes, and it keeps increasing because now it will be saving everything inside this file. So this is the main file. The other files are all secondary files that can be deleted later on, as we'll see. So now let me click on the monitor to see what's going on with the analysis. So this is my job monitor. Let me make it a little bit bigger and wider. So right now you have this big table in the beginning that has like multiple columns. So this is where we are going to see our analysis while it's being run. So the first one, it says the step. This is the increment time. The most important, like if you have any severe continuity during the iterations. These are the attempts during the iterations for the solver. This is the total time. You are going to see the total time of your analysis. This is the step time. And finally, this is the time increment. Okay. And over here, we have multiple tabs. The first one is the log. So this is the date and the time at which the job is submitted, and the processor has started for the analysis, and it has completed, and now the actual analysis has started. And once it's finished, you are going to get a message that analysis has concluded. Errors, of course, if you have an error, the analysis will stop and you are going to get an error. So right now there are no errors. This is good. This means there are no major problems in our model. Warnings. So this here you are going to get some warnings, and let's look at some warnings that we already have here. So the first warning, it says that the general contact domain for modeling contact interactions has double-sided facets, and initial contact adjustment for resolving gaps and overclosure. So this is a very common message that you are going to see, or a warning, whenever you are doing some kind of interaction. And pretty much it's telling you that some adjustments are being done to the surfaces to make sure that surfaces are just in contact. So if you have any precision problems, it's all sorted here. Then here it's telling you that make sure that the mesh density of the slave surface is finer than the master. So this is what you should typically do whenever you have a slave surface. The mesh on it should be finer than the master surface. So you need to make sure that this is the case. This is more recommended. And then again here, it's telling you for the tie pair. So this is the beam end to the end plate. Again, adjusted nodes with very small adjustment were not printed. So again, these are all some small adjustment that the program has done in the beginning. So this is nothing major. So now, as you see here, now I'm starting to getting some entries in my table. So now I'm step number 1. Well, of course, because I only have a single step. Right now, I'm having severe continuities, and I didn't advance yet. Now I started with the first time increment. Remember that this is what was specified when we defined the step. So we're starting with 0.01. But seems that at 0.01 there is a problem. Actually, I'm getting warnings here that the displacement increment for contact is too big. So this means that there is large deformation happening in the model at this point, that it's too big for the contact formulation. So what ABAQUS is trying to do is trying to decrease the time increment and try to reanalyze. So that's why the time increment now dropped from 0.01 to 0.0025. All right. If you remember, the smallest time increment that we specified was like 10 to the power negative 15. All right, so now ABAQUS is going to the smaller time increment and it's trying again. And then you are getting some some warnings here that the strain increment exceeded 50 times the strain that causes yield at this number of points. So this means again that there are lots of deformation happening in some elements. So this could be because of the loading. Most probably we are getting this issue in the beginning because if you remember, we are applying the axial load in the column using the constant amplitude. So right from the beginning, we are applying the entire axial load in one shot. So this might cause this issue. So you can modify these things later on. You can apply it in a ramp, maybe in a different step, so that this thing doesn't happen when you apply very large load like instantaneously all of a sudden. But right now, you see, now we are going better. So right now, ABAQUS has resolved this issue. Like you had some problems with severe continuities and so on, but right now you are moving ahead. So right now, the total time or the step time, which are basically the same in this case because we only have one step. So these two columns provide the same value. But anyway, for the step time, so you see now that you are advancing. So right now, ABAQUS have went through 0.002 seconds. So if you remember here, so right now I have 1 second. This is the total time. So right now ABAQUS have finished 0.001 seconds. So we're still pretty much in the all the way in the beginning. But things are going right now. So now you have the increment numbers. So in increment number 1, you had some problems with conversions. So that's why it took like 3 attempts to reach conversions. And right now we seem to be proceeding better because as you see, the time increment it decreased until ABAQUS was trying to resolve the conversions problem. And right now the time increment is increasing back again. So this means that our model is going, and whatever the issue that we had in the beginning has been resolved, and now things are moving forward. If I scroll back in the warnings, you see here the last warning here, it says that excessive distortion and at a total of 75 integration points. So again, this could be related that maybe we didn't pay much attention to the mesh element at some locations. That again, it's causing a little bit of distortion. So these are again things that can be refined later on. But as long as it's not in the error, or it's not causing an error, it's not stopping the analysis, this should be fine for now. So now here we go. We see the analysis, it keeps going. You have other tabs, by the way. So this is the data file. So this includes information about your run, the definition of the model, how many elements, and so on, or the problem size, the number of elements, the number of nodes, the number of degrees of freedom. All this information can be found here in the data file, which you can view it here, and in the same time in the work directory. Actually, this should be, if I remember correctly, this file, like STA, these are all ASCII files that you can just open. So here is this one, the data file.dat. So this one you can just open it with any text editor, and you can read pretty much the same things that you are reading here in the monitor. Notice here again that the time step is going higher again. So now we are at 0.01 and it keeps getting bigger. So this means I'm having lesser problems. I don't have severe continuities anymore. So this only happens in the beginning. And this is very typical, like most commonly, like if you just pass the first few increments with no problems, then everything is smooth sailing from now on. So now everything is going. Right now I'm at 0.07 seconds, and we are trying to reach 1, of course. This is the message file. Again, it has some informations about the different messages or different things, the checks of your model. But anyway, like all these information that we're seeing here are in those different files that are being generated by ABAQUS. And this is the status file, and this one is summarizing the same thing that we are seeing here with this table. It's summarized in this status file, which is this one. So this is this one, STA file. So actually, if I open it, you can see the same information, and it will keep updating. So I can read this externally, actually, without with an external program. I can read this file directly and monitor what's happening in the program without opening the CEE itself. Let's go back to the warnings. Okay, there are no new warnings, so everything pretty much is all the problems that we had in the beginning with these severe continuities, but right now everything seems to be going fine. So right now I'm reached 0.12 seconds, and you see here that the time increment it keeps getting bigger and getting smaller depending on if I'm having any problems with conversions or not. Ideally, if you remember, we mentioned that we specify that the maximum time increment that the program can go to is 0.1. So if the program reaches 0.1, this means that you have no problem and the program is making use of the maximum time increment. So it seems there is nothing happening now. The only thing that we can wait is to wait for the analysis to conclude. Basically, until you reach 1 second, this will be finished. Of course, if you have an analysis that you have multiple steps, then you are going to finish the first step, then you are going to finish the second step, and so on. And the total time here, as we said, it's the same as the step time because we have one step. But if we have two steps, for instance, and the first step is like 2 seconds and the second step is 3 seconds, then the total time will be going from 0 to 5. Okay, but right now, because we have one step that goes from 0 to 1, the total time will be the same, goes from 0 to 1. So it's very important to have an understanding of what these symbols and what these numbers mean, to understand what's happening in your program so that you can fix any issue that might happen during your model because of any problems. So again, most of the errors that we are getting, excessive distortion, too much strain. Again, this could be because we are applying, the fact is we are applying lots of load and there is lots of deformation in our models. And it could be also because of the mesh. If the mesh is not ideal, then you can get these problems. So actually, if we have done a poor job with the mesh, most probably our program would have stopped right from the beginning because of conversions, and you are going to stop and you will not finish the analysis. So that's why it's very important that the mesh is correct. So right now we are almost 1/4 through. So let's wait for this to finish and then we are going to discuss the results. Right, so this now concludes the analysis. So now we finished, now we reached 1 second. So this means the analysis has been included and this has been finished in a total of 38 increments. And if I go back to the log, it says here that completed. So the analysis has been completed over here, and it took roughly about less than half an hour to run this analysis on my PC. So this is not bad. Of course, we can reduce that by optimizing the mesh more in later refinement of the model. So I will dismiss this monitor, and the next thing, of course, that we'll need to do now is to access the results by clicking on results. Notice here, by the way, in the work directory that right now the ODB file, right now it's about 400 megabyte. So this is the size of the ODB file. Of course, if you have lots of elements, mesh elements, and if you have a larger model, and if you're saving all the field variables, this ODB file can reach very large size. So that's why you try to keep things optimum and only save the things that you need. So in the next video, we're going to check the results and check what is our output.